Alright, good day my fellow chemalites. Today I'm going to be making our final video on carbon. Alright, we stopped on like in our last video, that is the part 2 of carbon, when we're talking about what the compound CO2 means and points to note about CO2. And that is that. Now we're going to be talking about the laboratory and the industrial preparation of CO2, which is carbon dioxide. Alright, first of all, we are going to be talking about the laboratory preparation. Okay, now, when you hear the word laboratory, you already know that it's prepared in the lab, and anything prepared in the lab is in small quantity. And now there's an instrument used in preparing little amounts of compounds and elements in the lab, which is very fast compared to the industrial preparation. We use kit apparatus to prepare compounds in little quantity and very fast. So anytime you hear kit apparatus, what comes to your mind is that an instrument used to prepare compounds in the lab fast, quickly. So that's that. Then the industrial preparation is it means when you hear industrial, you mean it has to do with large quantity. You are trying to make this compound or this element, produce it in a very large quantity. Okay, so now let's move on straight up to the industrial preparation of CO2. Alright, now CO2 can be prepared in the lab with the action of triazocarbonate 4 and a mineral acid to give us CO2. So now let's write the equation. Now we're going to use calcium triazocarbonate to react with what? The mineral acid. What is this mineral acid? We have H2SO4 as a mineral acid. We have HCl, but we're going to use HCl. Okay, now we use HCl. Now when these two react, what will they produce? They will produce calcium chloride. First of all, calcium chloride. What next? They will produce what again? They will produce, from the look of things, water will be formed. H2O will be formed. H2O will be formed. Lastly, what we are actually looking for is what? CO2. Now we've gotten it. But from the look of things, this equation is not balanced yet. We have 3 oxygen here. We have 1 plus 2, 3 oxygen. We have 2 hydrogen, 1 hydrogen here. It's not balanced. We have 2 chlorine here, 1 chlorine here, and 1 calcium, 1 calcium. So what we have not balanced yet is our chlorine and our hydrogen. So we have to now put 2 here. Putting 2 here, we make this hydrogen here 2, make this chlorine 2, and that's for that. So we balance this equation. So whenever we are talking about the laboratory preparation, we are talking about this reaction. Alright. So now moving on to the industrial preparation of CO2. It's easy. Actually, it's the thermal decomposition of limestone. Okay, when we are talking about limestone, what do we mean? This is what we mean by limestone. Triazocarbonate. That is calcium triazocarbonate. It's called limestone. So now, this is what you just write in the reaction for the industrial preparation of CO2. When this guy undergoes thermal decomposition, okay, now when you hear the word thermal decomposition, what comes to your mind? It's simple. When you hear thermal, first of all is heat. Decomposition is the breakdown. So now, when heat is added upon this compound here, it will decompose. It will decompose, that it will break down to smaller compounds, which will give us calcium oxide and what? CO2, carbon dioxide. Okay, now from the look of things, we don't have to balance this equation. This equation is balanced. So alright, this is all about the industrial and the laboratory preparation of CO2. So now we have to move on to the next stage, which is the reactions of CO2, the properties, chemical properties. Now we have 2 properties of CO2. See, the first one is the acidic nature, second action with lime water. Now I'm going to explain it. Okay, first for the acidic nature, I said it before in our former video that is the acid acid oxide, acidic oxide of carbon. That CO2 is the acidic oxide of carbon. That's what I said. Okay, now let me explain. CO2, which is carbon dioxide, is soluble in water. So now, like, it can dissolve in water. So when CO2 dissolves in water, it will form a weak dibasic acid. This is what we are trying. That's what we are trying to say. That weak dibasic acid it formed is why we now classify it under one of the property as it has a acidic nature, which is why we can say that CO2 is an acid anhydride. You understand? Because it can form acid when it reacts with water. That is why it's called acid anhydride. Alright, so now let's write the formula. When CO2 reacts with water. Now note, this CO2 is what? We all know is a gas. Then this one is a liquid. Now they will form a weak dibasic triosocarbonate 4 acid. Now it will form the weak dibasic triosocarbonate 4 acid, which is what? Aqueous. It's aqueous. It's an aqueous state, which means it has is like a solution. Yes, it's not a liquid, neither is it a gas. So it's like a solution. You get. So now moving forward, what next? As an acid anhydride, which CO2 is, it has other reaction which it undergoes, which is why we classify it as an acidic oxide. Now, when CO2 reacts with what? An alkalis. When it reacts with an alkalis, it will form what? It will form a salt and water. That is why it's classified as an acidic property, because all acid react with alkalis to form salt and water. You get me? So now you must be wondering what alkalis is. And it's a base. It's as simple as that. You know, if you know what base and acid is, you won't have issues with it. This is a base. This is an acid anhydride. So when they react, they will form salt. So which salt will they form? Sodium triosocarbonate and water, as I said earlier. Okay guys, from the look of things, we can see that this equation is not yet balanced. So what do? We have to look at it. We find out that sodium is 2 here, only 1 sodium here. And looking at it, we have 3 oxygen here, 3 oxygen here. Good. Okay, that's good. Alright. So carbon 1. We have to put 2 here and put 2 here. Now, if you calculate, you will find out that the equation is now balanced. Alright. So, okay. Now, moving on. What do we do next? Yeah, there's one final reaction which makes CO2 an acidic anhydride. When there is excess CO2, which means after this reaction has taken place, it has formed an acid and a salt and water. Sorry, that is formed a salt and water. What next? In the presence of excess CO2, this reaction here, let's write it. Sodium triosocarbonate and water with excess CO2, carbon dioxide, it will give us what we call baking powder. Note it, baking powder. Okay, This is the formula for baking powder, note it. Alright, so now from the look of things, we can observe that this equation is not yet still balanced because we have two hydrogen here, one hydrogen here, one sodium here, and one sodium there. Sorry, I missed this. Two sodium here, one sodium here. And so, what do? We have, I think, 4, 6. We have six oxygen here, but we have only 3 oxygen. So what do? We just have to put 2 here. And voila, the equation is balanced. So now, next up, we have to look into the second property of CO2. Now, this action with lime water. Action with lime water is also used as a test for CO2. Alright, this is a very popular question. So now let's move on. I will explain it now. I will show you how this question is being placed most times in an exam. Alright, moving forward. Alright, talking about the test for CO2. We have a compound called slake lime, which is written with the formula calcium hydroxide. So now, slake lime can also be called calcium hydroxide. It is in a what? Solid state. Now, in the presence of a water molecule, or we can say when it reacts with a water molecule, but we don't know how many water molecules, so we can just write N to represent number. Any amount of water molecule. What will happen? This slaked lime will turn to, let me write it. Slaked lime will turn to what? Lime water. Now, see the formula. The two looks identical. So, but you have to know the difference. To become lime water. But this lime water is not in a solid state. Due to the presence of water, it's become aqueous. Alright. So now, as I said earlier, aqueous is in a solution form. This now is now called lime water. It's called lime water. Note this. So alright. This lime water now is what we use in testing CO2. Alright? Now, CO2 reacts with what? Lime water. To give what? Now, it will form a white precipitate. This question is a very popular question. Yes, it's a very popular question. When these two react, when CO2 reacts with lime water, it will form a white precipitate, and water. So now this white precipitate, what is this white precipitate? Is also limestone. It will form calcium triazocarbonate and what? Water. Alright. So let's check if this equation is balanced. How many oxygen do we have here? We have 4 oxygen here. We have 2. We have 4 oxygen, 1 carbon here. Alright, so we can say this equation here is actually balanced. Alright, so aside this, now if you look at this reaction, we've gotten our limestone and water. But wait, remember, This is the white cloudiness or white PPT that is formed. Let me just write it. White PPT is very popular question. So now when this white PPT is formed, when we put excess CO2 to this lime water, what will happen? This white PPT will disappear. Why? Now you will now ask me why it disappeared. What happened? A calcium hydrogen triosocarbonate was formed. Alright, so now let's write the formula. Now, from our products that we have gotten, we rewrite it. Calcium triosocarbonate plus water molecule plus what? Excess CO2. This is now the fun fact about it. When this excess CO2 is now put in the product side, we react it. What will happen? A product is formed, which we call calcium hydrogen. So now this, you put it in the bracket, calcium hydrogen triosocarbonate is formed. Now the white PPT will disappear like that. So now it's a question. So you have to note the part whereby CO2 reacts with lime water to give a white PPT and water. Now the next thing you do is that you note it in your head that when this product side, that is limestone and water and excess CO2 react, will give us what? Calcium hydrogen triosocarbonate 4. That process, the white PPT will disappear, the cloudiness will vanish. Alright, that's all you need to know about the reactions and the chemical properties of CO2. Okay guys, about CO2 and the greenhouse effect, there are things I want you to know. Now, first of all, let me tell you the processes. When the sun brings in heat to the earth, cosmic radiations, which is infrared. Alright, when this radiation get to earth, normally with time it will like go back, but going back, normally we have, I think I noted this point when I was talking about CO2 in our part 2. I said we have 0.03% CO2 in the atmosphere, but due to burning of bushes and combustion and other things leads to increase in this CO2, carbon dioxide. So now, due to the increase, it will now be merged in the lower atmosphere, which we call troposphere. Now, when this thing is merged in the troposphere, it starts trapping heat, cosmic radiation, the infrared, they start trapping it and sending it back to Earth. Now, what will it cause? If it starts trapping them and returning them to Earth, it will cause, like, it will increase the temperature of the lower atmosphere by 2 degrees Celsius. Note that. So when this thing has taken place, we call it global warming. So now, this global warming is also called the greenhouse effect. So I'm going to tell you the major effects of this greenhouse effect. It causes flooding. Do you know why? Anytime you see a question like what is the major effect of greenhouse effect or global warming, what should come to your mind? Flooding. Why? Because of the increase in temperature and sea level. There's an increase in the sea level, and apart from the sea level, there's also a depletion of the ozone layer. Okay, we have other gases which causes global warming or perhaps greenhouse effect. We have other gases, but CO2 is the major one. Okay, now let me list them. The first one you should know is CO2, which is the major one. Secondly, we have methane. And again, we have CO, carbon monoxide. And finally, of all, we have compounds of sulfur, e.g. SO2 and SO3. Okay, these are the compounds which are responsible for global warming. So I want you to note this: carbon dioxide, methane, carbon monoxide, and compounds of sulfur, which are these two. So now just notice these are all the greenhouse effect gases. But the major one, anytime you hear which of these is the major greenhouse effect gas, is CO2, carbon dioxide. Alright, before we move on to the uses of CO2 and finally the triazocarbonate, first of all, I want you to know this. It's just for you to know it. It's not really an industrial preparation, the major industrial preparation of CO2. When sugar, this is the formula for sugar. When sugar is fermented, it will form what? It will form alcohol. It is fermented by an enzyme, zinase, to give us our alcohol. And we have our CO2. Alright. Now, but this equation is not balanced. Let's balance it. We have to put 2 here. We have to put 2 here. Okay. Now, the equation is actually balanced. Alright, so just note it. When sugar is fermented, it will give us alcohol, and CO2 is also an industrial preparation of carbon dioxide. Alright, I just want you to know that. Uses of CO2, we have about 5 of them. First of all, I want you to know that it's used for carbonating of drinks. That's the first one you should note. Secondly, it is used as a fire extinguisher. Okay, now, why is it used as fire extinguisher? Because it does not support combustion. Secondly, it's 1.5 times denser than air. So this is why it's now used as fire extinguisher. It does not, the major one, it does not support combustion. Alright. Thirdly, is used as fertilizer. Why? Because it's used in the production of urea, which is used to produce fertilizer. Now, the fourth one is used in what? Used in baking. Now, you now ask me, why is it used in baking? When CO2 is added to the dough used for baking, it causes the dough to rise. So now that is why it is used for baking. Then finally, dry ice or hard ice is used as refrigerant. Alright. So now you now ask me what is dry ice and hard ice. Okay, dry ice and hard ice is the solid state, or we say dry state of CO2. Now, when CO2 is produced industrially or in laboratory, how do we turn it to dry ice or hard ice? It is now subdued into pressure, which will liquidify it before it's now compressed to the solid state, where it is now called dry ice or hard ice. So anytime you see a question like what is the solid state of CO2, what comes to your mind is dry ice or hard ice. Is that clear? Okay, finally let's move on to the final stage of this video, where we talk about the triazocarbonate. Okay, now what we need to know about triazocarbonate and hydrogen triazocarbonate is not much. First of all, the hydrogen triazocarbonate is a weak dibasic acid, which in steps form two salts. Okay, now first of all, I'm going to give you the salt which each of them forms. Now, first of all, our triazocarbonate. Our triazocarbonate four salts are, we have sodium triazocarbonate, and we have calcium triazocarbonate, etc. Okay, for our hydrogen triazocarbonate, four salts. We have our baking powder, and finally we have our calcium hydrogen triazocarbonate. Okay, etc. Now, I believe this one is familiar already. We talked about baking powder, sodium hydrogen triazocarbonate. Then this one is what I told you, that when excess CO2 reacts with the white PPT and water, what will happen? The white PPT will disappear and calcium hydrogen triazocarbonate is formed. So this is it, these two compounds. Okay, now one thing, now I want you to note these two rules. There are many rules. Actually, I'm going to name about 4 or 3 or so. Yeah. No. All hydrogen triazocarbonate salts, all hydrogen triazocarbonate salts are unstable to heat. Just note it. All hydrogen triazocarbonate salts are unstable to heat. What do we mean that are unstable to heat? They decompose on heating. Anytime small heat touches them, they start decomposing. That's for hydrogen triazocarbonate. Then now, all triazocarbonate salts are all triazocarbonate salts of pass. I'm coming, I'll explain what I mean by pass. Are soluble, but the rest are not soluble, they're insoluble. Okay, now what I mean by pass is potassium, ammonium, and sodium. You get potassium, ammonium, and sodium. All triazocarbonate of potassium, ammonium, and sodium are soluble, which means they can dissolve in solvents. But the rest are insoluble. Just note that. Am I clear? Alright. So now the next rule is okay. Now the next rule, we have only the triazocarbonate of PBS is stable to heat, while the others decompose to give their oxides. Now, what I mean by this, I mean that only the triazocarbonate of what? Potassium, barium, and sodium is stable to heat. Now, what do we mean by stable to heat? We mean that they don't dissolve on heating. You get? No matter the amount of heat you put on them, they can never decompose on heating. You understand? Maybe they can decompose by adding a catalyst, but they will not decompose on heating. Do you understand me? While the others decompose to give their oxide. Now, what do we mean that the others decompose to give their oxide? Like, we have zinc triazocarbonate. In the presence of heat, they will decompose to give zinc, to give zinc oxide, and to give out what? They will give out what? CO2. You see. Also, Pb, which is lead, triazocarbonate of lead, on heating, we give it oxide. And so you see what I mean by they will decompose to give their oxide. Zinc and lead, they are triazocarbonate. On heating, we give zinc oxide and lead oxide and liberate CO2. Okay. B, triazocarbonate of silver decompose to give metallic silver. Okay. Note that the triazocarbonate of silver decomposes to give metallic silver. Like, if you see these ones, zinc and lead, when they decompose, what do they give? Their oxide, and they will liberate CO2. But silver is different. Silver does not it does not give its oxide. It brings out the metallic silver. So now let's go. When silver triazocarbonate on heating, follow me, on heating, it will give us what? A metallic silver, and what? Liberate CO2 and finally oxygen molecule. From the look of things, this equation is not yet to be balanced. Okay, now what do? We have two silver, one silver. Okay, let's make this oxygen 6. If we make this oxygen 6 by putting 2 here, and we have 3 oxygen here, we have 4 oxygen here already. We add here 2 here to make it 6 oxygen. Okay, 2 times 2, 4, plus 2, 6. Now we already have 4 silver here, so we have to add 4 here to balance this equation, guys. So now this equation is balanced. So just note it. During the decomposition silver triazocarbonate, 3 things will be liberated: a metallic silver, carbon dioxide, that is CO2, will be liberated, and oxygen molecule will also be liberated. Just note that. Okay, there's something I want to clarify. There is nothing like aluminum triazocarbonate. For it does not exist. The salt does not exist. There's nothing like aluminum triazocarbonate. It can't combine, it can't work. So don't remove it from your mind. Anytime you see it in a question, no, it's not the answer. Just know, except they ask you which of these is not a triazocarbonate of triazocarbonate, first salt of triazocarbonate. If you see silver there, maybe if you see aluminum there, you know that's the answer. There's nothing like aluminum triazocarbonate. Please note it, put it in your head. There's nothing like aluminum triazocarbonate. Alright, okay guys, this is the end of the class. Thank you for watching. If you followed from part 1, part 2, and finally here, you're a true Kenilite. Thank you for watching.